Good afternoon, everyone. Again, it's 2 p.m. So let's start our seminar for today. Our speaker today is Dr. Chait Bhat. He's a sustainability engineer at the Asphalt Institute. He earned his PhD in civil and environmental engineering from Michigan Tech University, specializing in developing environmental product declarations, EPDs, from life cycle information models. He is a certified life cycle assessment practitioner by the American Center for Life Cycle Assessment, and he collaborates with pavement and environmental sustainability stakeholders, working on tactical and strategic sustainability initiatives. We are very pleased to have Dr. Chait with us today to share their expertise in sustainability. So let's give a welcoming round of applause to Dr. Bhat.
Thank you for that kind introduction. Hope you are able to hear me fine.
Yes.
Yeah, thank you. So, thanks for that introduction. I work with the Asphalt Institute, so I'm a civil engineer by training. Hopefully, we'll be able to relate to most of you people, not at the depths that you may be, because I know that I'm amongst esteemed researchers here. So, this is a brief content of what I'm going to go through. We'll start with the very broad pavement sustainability definition, which Dr. Al-Qadi was key in formulating as part of a federal highway research back in 2013 to 2015, and then focus specifically on the environmental component of sustainability, which is in the forefront these days. And what does it mean from a construction materials context? Want to kind of boil it down to that level. And then some tactical initiatives, like basically policies. So where is money being funded right now in terms of green public procurement and opportunities for you guys and your research that you're doing? And in addition to that, like more of strategic sustainability pledges, like where is the industry kind of moving in terms of for the next 20, 30 years? And then both tactical and strategic, some of the considerations in terms of tactical EPDs and strategic more of net zero arena. And then we'll have question and answers. So if you have any questions anytime, please stop me because I don't want this to be a one-way thing. Let's make it more interactive. So this on the right, you see and a better image that our marketing team created, but the definition on the left, the 4 pillars is what I call performance being in the core. Oftentimes, when we talk of sustainability in isolation, we talk in terms of triple bottom line, social, environmental, and economical aspects. However, performance of any particular domain is key component which will affect these triple bottom line aspects. So that's why we see this, and this is from the FHWA report that Tom Van Dam was a lead author, but of course, Dr. Al-Qadi and others were key part of it in developing that particular report. So let's focus on the environmental component for today, because I understand there are other experts who can talk better for performance and others. So what I'm related to is more on the environmental sustainability side. So I want to focus more on that. So why are we focusing so much on environmental sustainability? Very broad terms, if we have to talk it in terms of that. So, and specifically in environmental sustainability, we talk in terms of carbon emissions, right? And this, I won't go through the definition. You guys might already have seen the definition of climate change, which is standardized by the Intergovernmental Panel. This is kind of the root cause, or like say the root problem that everyone's trying to address. And IPCC provides that resource, talks about how can we mitigate these. So they have come up with some formulas, some models, some numbers that different governments across the world are utilizing to develop context-specific policies. Paris Climate Agreement being one of them, where you can see it was a global collaboration of 120 countries and somewhat other companies that pledged to keep the global temperature rise below 1.5 degrees centigrade by the end of this century. Now, how many of you have done life cycle assessments or are familiar with life cycle assessments? Yes, Dr. Al-Qadi, I know you are. Yes. So do these numbers ring any bells just by themselves? I'm sure for some of you it might, because when we talk of this whole emissions, right? How much? What is that budget? Like we are channeled to think in terms of money. me as a grad student, I knew how much my scholarship was and how much I'll have to utilize out of my bank loan. So this is think in terms of carbon budget. This, and of course, as with any models, these have uncertainties, but these are those numbers that's put out by Intergovernmental Panel on Climate Change that if we want to, like say, limit the rise of temperature above 1.5 degree, what's the 2/3 chance is that we control the emissions like to 420 gigatons of CO2 by the year 2050. Now to go there, where are we currently? Like if we continue things as is, it's going to be around 52 to 58 gigatons of CO2 in 2030. But is that sufficient? No, we have to reduce it down to like 25 to 30 is what the report says. So basically 45% reduction in 2030 as compared to the levels in 2010. And net zero in 2050. I'll explain in the next slide what this net zero term is. But in order to do that, it's not going to happen just like say by the wink of like say a magic wand. It's not. You need significant funding. And the estimated funding by the panel government is around 830 million USD per year from 2060 to 2050. And you can think in terms of GDPs of countries and map it back to how much this amount covers. So for more nerdy stuff on climate science, this is the link that you can, so the presentation is shared with you guys so that you can go into this and take a look at it in more detail. So now net zero, you have heard many industries pledge net zero, many governments pledge net zero. Are we meaning zero emissions? No, it's not really zero emissions, but kind of balancing, as I talk here, balancing the amount of energy that's produced and removed. Produced by whom? Produced by humans, because anthropogenic. So there is, of course, historic temperature rise and historic climate change. So these models do take into account some of that and add the uncertainties. However, in case of net zero, when we talk of net zero, there will be emissions, but there are going to be ways where the emissions will be sequestered or captured. So things like carbon capture sequestration, direct air capture, multiple technologies that might be not out there today, like direct air capture, but might be out in a few years. But this is the central idea around net zero. How many of you have seen this diagram before? So this is when we talk of net zero, what emissions, right? So I stopped by my friend's house yesterday. He works for Cummins, the engine. I would like to explain in the context of if Cummins has already pledged net zero by 2050. So there are 3 types of emissions that they will have to cover in order to be true net zero. One is scope 1, where it's basically all the manufacturing emissions that happen on site within Cummins' different manufacturing sites that they have. So all the emissions from the electricity they consume or fuels they consume, all of those on-site events would be scope 1. Now, what is scope 2? Scope 2 is they will use the electricity and energy sources on site. However, are they produced there? Some of them might be, but most of them are procured from somewhere else, right? So the grid electricity, the emissions coming from that grid electricity, as well as the fuel sources that are the production of fuel sources, like refineries or others, is the scope 2 emission. Now, scope 3 is tricky because scope 3 can exist both upstream as well as downstream. Now, upstream scope 3 would be in the case of Cummins, if they are getting small components from different suppliers. What are the emissions that have gone into the production of those components would be the upstream scope 3. Now, downstream scope 3 would be once those engines are fit into different kinds of vehicles, firstly, the transportation, the assembly of those into the vehicles, and then their durability component. If you want to think in terms of pavements that we are all used to, you can see, for example, the downstream scope 3 would be all the use phase stage aspects, which include the performance that most of you research on. And that's where you can find the link between the work that you do and what's required to quantify these emissions. Now, what does this mean in the context of construction materials? Okay, we need global net zero and we need so much reductions. This is taken from one of our global members, Shell's report, decarbonization report, that they worked with the consultant Deloitte. On the left-hand side, you see the global carbon emissions. It's just global carbon emissions. And when we talk of embodied emissions, what we are referring to is basically the emissions from the manufacturing of those materials, right from raw material extraction, transportation to the plant site, and its manufacturing. Now, there are multiple definitions of embodied carbon out there, like Carbon Leadership Forum out of University of Seattle. They include even use, construction, use, and disposal within embodied carbon. However, in this diagram, embodied carbon is just referring to the cradle to gate, is what I call it, material extraction to its production. On the right-hand side, you see the context that out of the global carbon emissions, 16% is from the construction embodied carbon emissions. This is from just from one report that I'm citing. And within that, if I'm looking at asphalt, now I have to talk about the company that I work for, right? So the asphalt is within that 24%, where other materials, there are like 4 materials there within those 24% range. So cement, for example, contributes to 43%, iron and steel contribute to 25%. But this kind of gives you a rough idea in the context that we as civil engineers or pavement engineers have to focus on for when it comes to construction materials. So let's start with the tactical initiatives first. What is the government doing to reduce these emissions? Are they spending any money? So I don't want to steal the thunder that Migdalia will have next week when she'll do a virtual presentation, but this is for us, for example, why is Asphalt Institute right now developing an environmental product declaration program for asphalt binder? As you can see here, in the orange states are the ones where there are already Buy Clean legislations passed. What is Buy Clean? Basically, the state agencies will be taking these mediums called as environmental product declarations, which I'll talk in a bit, use a metric, global warming potential mentioned in the EPDs, and establish thresholds based on the EPDs they'll collect. So for 2-3 years, they'll collect the EPDs, establish thresholds, and after that, they will be requiring manufacturers to lower the emissions and only award contracts based on that. So that is what the Buy Clean policies currently mean. In addition to the Buy Clean policies that were passed at state level, like California was the first one to pass it in 2017, Colorado passed it in 2021, and after that, there are multiple states. And Colorado is the only state right now requiring EPDs not just for asphalt mixture, but also for asphalt binder, not just for concrete mixture, but also for cement. Now, Inflation Reduction Act provided the more money and power to EPA, Environmental Protection Agency, at a federal level. On the left-hand side, as you can see, authorizations to various government agencies, as well as the funding. And the purpose is where you can see for what. So for example, currently, just last week when I was in Vermont, the EPA announced at the ACLCA conference that they now have $100 million grants to support the development of EPDs. And within the support, there is a NOFO out there for your reference. They have things like robust data development for EPDs or standardized guidance for product category rule. I'll explain what those are in the next slides, but this is where the money is kept right now. And then, in addition to the EPA's support to developing EPDs, the agencies like Federal Highway Administration that are looking at like horizontal construction, General Services Administration that are managing the public buildings but vertical construction, have been awarded like approximately $2 billion and $2.15 billion to support the procurement of low carbon material. So once they define what's low carbon, what's the scope of low carbon, and what's that threshold, if the innovative materials, as they call it, cost more than the traditional materials, then these funds will help them procure that, or like match that gap and procure those costly materials. That's where all of this is going. Now, I've talked about product category rule. I mentioned product category rule and environmental product declaration. So let's briefly look at what it is. This schema that I have here is on the right side, rightmost end, you have environmental product declaration or EPD. That is what is being mentioned in both IRA funds as well as in the Buy Clean policy. Now, why is EPD the medium to go to? That was selected by these government agencies. It's because there is more rigor to the process of developing an environmental product declaration than just conducting a life cycle assessment. So as you can see here, the fundamental rules in order to develop a product category rule or an environmental product declaration is provided by, in the US, we follow ISO standards, International Organization for Standardization standards. In Europe, they follow EN standards. There are similarities and a bit of differences between both the standards. However, they act as the core rules. So it all starts with having a program operator. So now Asphalt Institute has contracted a program operator called Smart EPD. What does this program operator do? They will firstly create a PCR committee. Now, Dr. Al-Khadi and myself are on the PCR committee for asphalt mixtures that's created by National Asphalt Pavement Association. Now, NAPA's difference is NAPA is their own program operator. However, in our case, we had a member-only task force that interviewed outside program operators and LCA consultants. And in my opinion, it's better to have an external program operator just because when an association themselves might be a program operator, there's of course some sort of subjective opinions that might arise, which absent when there is an external voice involved. Now, this product category rule, think of it like a rule book. Now, we are now used to material specifications, right? Or pavement design guides that give us information on what materials to choose or what thickness of pavements to design and for how long, how can we define design lives. Product category rule is similar set of rules, but for environmental product declaration. So it includes things like, for what are you defining these things? So are you going to compare a pavement versus another pavement, or are you going to do a material versus another material? So a life cycle assessment, which I'll discuss in detail in the next slide, supports the development of product category rule. So currently, Asphalt Institute has contracted with a company called Spera to develop an industry average life cycle assessment. We developed one in 2019, and this time it will be an update because of the primary data that we collect for members is only good for 5 years. It's the best practice to have it for 5 years or less. That's the reason why we're updating. And the end goal, it's not the associations that produce or sell materials, right? It's our members. What is the end goal is to develop an EPD tool that all of our members can use, because ultimately, if the materials engineer in Colorado is asking for an EPD for binder, it's our members like Suncor or Chevro or others who will have to provide an EPD, context-specific EPD for their material. And we are facilitating that EPD tool generation right now. So, life cycle assessment. It supports both PCR and EPD. As the name suggests, life cycle assessment is something that has to account for complete life cycle. So right from material extraction, on the right side, you see the ones for what we have within AI's organization. So asphalt binder is used in majority in paving, but also in roofing. So the life cycle of asphalt binder starts at crude oil extraction and is used in both paving applications and shingle production and building, like say, construction applications. And ultimately, end of life, it can be recycled, reused, or landfilled. But else, so think if you are already aware of life cycle cost analysis, which is counting in terms of money. Life cycle assessment is accounting in terms of potential environmental impacts. Like you're producing these things now, you're constructing these things now. What are the potential environmental impacts from these? And it's not pulled out of thin air. This methodology is based on ISO standards that I mentioned here, 144.0 and 144.4. So if you want to start somewhere in terms of where should I start for life cycle assessment, these are great standards to refer to, because think of it like fundamental theorems that you can then apply it to whatever context you're doing, because you need to deduce the fundamental theorems that are mentioned in ISO standards to your context. Now, here is a framework for life cycle assessment. You start with the goal and scope definition. We call this as life cycle phases, 4 life cycle phases. Your goal can be, for example, if you are a state DOT engineer, your goal can be to, from your decision tree, you'll have certain treatments in mind. So you want to compare different treatments for the next 20 years or 30 years. So your goal can be to evaluate those alternative treatments for that particular reference life. For that, what we'll do is, okay, now we understood what our ultimate goal is, so we'll have to define a scope. Because you can't include everything under the sky, right? So you'll have to start somewhere and end somewhere. That's your scope definition. And also you'll have to define things like what is the unit. Now, for a typical material, it can be per kg, per short ton, but when we talk of pavements, it can be an X lane mile of pavement serving Y amount of traffic under Z climate conditions, under this subgrade. So you'll have to think of all that. And then do we just have one truth, one true design? It's not, it's context specific. So you need to define scenarios of multiple treatment types that might be out there. Once you have all this kind of gives you the skeleton. But now you have to fill the skeleton with data. That's your inventory analysis. What data? Resources, okay, materials, energy, water. And then your final product, like asphalt binder, I start with crude extraction, refining and all that, and I have asphalt binder. But is that the only co-product? There are other co-products in asphalt binder, like the fuels and others that come in, and then also emissions. So both your input and output data is what's compiled in an inventory analysis. However, is this sufficient? Okay, I'll get all the emissions, carbon dioxide, methane, nitrous oxide. Can I make these into some meaningful matrices? That's the impact assessment. It's where you take these individual emissions, classify them to specific impacts. For example, global warming potential, carbon dioxide has a different potency and also different lifetime to cause global warming potential. And so does methane. So you compile all of those and characterize them as per their respective potencies and come up with these matrices like global warming potential, acidification. Sometimes it might be to water, so eutrophication. Now you have the model, you have the impact assessment. You can play around with it, right? That's your interpretation. Do we have any certain thing in life? We don't. Same here, life cycle assessment is very uncertain. So in interpretation, you'll now see, as a state engineer, you'll now see, okay, I'm taking material from this manufacturer. What if I take it from somewhere more closer? So you will reduce the transportation distance. What if I take it from somewhere who might be more expensive, but is giving me a more durable material? Then you'll take into account the service life and the design scenarios. And would the impacts be same throughout? Because electricity consumption at a plant, for example, varies from different seasons. So you have to account for the uncertainties. There are different types of uncertainties that you can do under interpretation. So this is your life cycle assessment. And for the data, specifically why I have the red box there is, your life cycle assessment is only as good as the underlying data. And when it comes to data, there are two types, foreground or primary data. Now for asphalt mixture, let me take a simple example, asphalt mixture. The plant manager who is managing the asphalt mixture would have direct data on the mix design, right? For which they have to produce it. And also the amount of fuels they are using, let's say for drying of aggregate and other applications. All that data is primary data. However, they need complete supply chain data. So they need to get electricity grid data. If their electricity is using so much percentage of non-renewables versus so much percentage of renewables, they have to account for that. So both primary and secondary data is what makes inventory analysis. And how do you choose, for example, the selection of primary and secondary data? Just because it's primary doesn't mean it's the best representative data, right? You have to decide on what time span of selecting the data for and other aspects. So these are some of the crucial aspects to look into when deciding on data quality. Now, on tactical side, what is the industry doing? So firstly, for asphalt binder, so I'm narrowing my scope to asphalt industry alone, but concrete industry and cement industries have also developed their own initiatives. Tom and I might have spoken about a bit of them, but then I'm sure if you go on NRMCA or ECPA's website, you'll get more information on cement and concrete. So as I mentioned, we started with the cradle to gate LCA scope for asphalt binder back in 2016. We contracted with a company called ThinkStep at the time. It's now known as Sfera. And we did it for cradle to gate. So we did not do cradle to grave because our members manufacture asphalt binder. If we want to do cradle to grave, we'll need to account for our downstream association, our pavement owners, have everyone into account, just because we can do an exercise where our members themselves get tools like pavements. and come up with scenarios. But that would be one industry perspective and not really a consensus-based perspective. That's why we limited it to cradle to gate. Now, foreground data or primary data was collected from 12 refineries and 10 terminals across North America. Background data, now Sphera, ThinkStep, has a default background data called GABI that covers the global crude oil production as well as refinery operations. And these were actually the product categories that we quantified the impacts for. So there is a report. You can follow the link. It's publicly available. And if you want to go more in depth, there's also the aggregated lifecycle inventories developed in multiple formats. So if you want to go and explore like lifecycle assessment through tools like OpenLCA, you can go in and import these data sets and build your own data models. Where are we now? So we now move from there to developing an EPD, right? So when I started with AI back in 2021, it was very hard to sell that we need EPDs. But luckily, Colorado DOT came up with a policy that requires EPDs from binder producers. So what happened is we created a member-only task force, had 40 plus members on that task force because we wanted to we invited everyone, 130 plus members, 40 plus were interested. And from that, it was an informed feedback on the selection of program operator, Smart EPD, who's now developing a product category rule. We had just 6th or 7th PCR committee meeting. And on the committee, there are 24 stakeholders, 24 or plus. So who participates on PCR committee is not just industry members, but we need to have external stakeholders like Federal Highway, Federal Aviation Administration, EPA, because that's the consensus-based process and the review that happens with PCR and EPD development, which has brought it to the forefront. And as I said, the LCA update is happening with Sphera, and our ultimate goal is to develop an EPD tool for binder. Now, our downstream association, NAPA, they developed their cradle-to-gate LCA for asphalt mixtures. Back in 2016 was the first LCA done, and they updated it in 2021. So they already have a tool for asphalt mixtures called Emerald Ecolabel. Now, the tool, I don't know, a tool might be purchased only. However, if you guys are interested, they have a website that will take you to their published list of EPDs. Now, the PCR committee that I said that Dr. Alkadi and I are part of was looking at some smaller aspect of this particular whole program. But this program has to meet every 5 years. They have to renew the PCR development, and the committee meets after every 3 years, I think. So now, tactically, you saw what were the policies, IRA policy, bike lane policy, and EPD, what's the methodology for that? Strategic, in terms of next 20, 30-year timeline, where are we seeing the industry move forward? This is just a schematic diagram of where does Asphalt Institute lie in the broader thing. So you see here Asphalt Institute. Our sister organization is Eurobitume, covering the European region. AI covers the North American region. Now our upstream associations are API, American Petroleum Institute, and Fuel Producers Manufacturing Association. And our downstream is associations like National Asphalt Pavement Association, Asphalt Roofing, ARMA, AEMA, Emulsions Association, Pavement Preservation, and Recycling. And our ultimate customers are Federal Highway, GSA, and other state DOT agencies. So just to give you an idea of the supply chain and where does Asphalt Institute lie, because the next slides that I'm going to talk about will give you an idea of what different things need to be done across the supply chain if we start thinking in terms of net zero. Now let's start with, yes, please.
What's GSA?
General Services Administration. So they also have $2.15 billion to procure low carbon materials, but they focus more on the buildings as well as the parking lots, if there is asphalt in their parking lots. In addition, so Federal Highway has $2 billion separately to GSA, but it's a government association. So let's start with very upstream. Our upstream association, API or American Petroleum Institute, they don't have a net zero goal, but they have a goal to decrease their emissions by 40% by 2040. So they have a climate action framework, and where they are going with that is they talk in terms of feasibility. Even the IPCC report that talks about we have to limit by 1.5 degrees centigrade or 2 degrees centigrade. But that also talks about the challenges, implementation challenges. So if we lived in an ideal world, then yes, definitely. However, as the demand and the population is increasing, the supply of these different aspects increases as well. Now, what is the oil and gas industry doing in terms of innovation or technology? For example, on the right-hand side, you see Oil and Gas Climate Initiative. That is like a CEO-driven effort. And they spend like $7 billion each year, $7 billion each year to come up with innovative schemas. So for example, carbon capture sequestration has been implemented across power plants. But that is a point source from which the carbon is captured. However, there are other innovative technologies like direct air capture and some of the others that are still in development. So in order to stay in business, because ultimately where this all is going is, their investors are asking them, what are you doing to prevent climate change? What are you doing to keep these emissions below these? That is the reason why some of these projects are in place. Now, for Asphalt Binder, what is relevant is you see this Pathways Alliance. In our life cycle assessment study, one of the things that we saw is for asphalt binder production, the crude from oil sands in Canada was majorly used. The reason for that being the heavier crude, the quality of asphalt, that correlation you can establish. So Pathways Alliance is an alliance between, I think, 90% or 95% of oil sands manufacturers to go to net zero by 2050. So since we lie intermediate in that supply chain, what we are hopeful is all that upstream innovations that are happening would be reflected in our downstream numbers that we get for some of these crude oil and others. Now, individual member companies, I won't go through each of them. You have the slides, have their own commitments. Some of them have complete net zero commitment. You can see scope 1, scope 2, scope 3. Some of them just have scope 1 and scope 2. As I said, whenever someone says net zero, just don't go by their statements. Just go a bit into that. And this audience, I'm pretty sure will do that, is go into them and see what are they saying when they're saying net zero. Because I'll give an example at the end of a failed system already around net zero that we are seeing in buildings arena. Now, downstream, our downstream association, NAPA, National Asphalt Pavement Association, they have announced to be net zero for asphalt mixture industry by 2050. Now, as part of it, they have also mentioned that they'll have net zero material supply chain. Now, what that means, they are looking at things like alternative binders and others, but also some of the net zero initiatives that are happening as part of asphalt binder industry would be reflected in their pledge. Now, our end customers, USDOT, they have announced system-wide net zero to be system-wide net zero by 2050. Now, in our Asphalt Institute has member meetings, 3 member meetings. In our annual meeting, we have invited a couple of folks, one from who is the climate policy lead at USDOT, who is formulating some of these net zero plans to understand it's not just the infrastructure component, but also the other mobility component that is tied into when they talk about net zero by 2050. And they have typically tied this within the climate justice and environmental justice action. So they haven't separated it, but because they wanted a program that's already existing. So they have kind of embedded it within the climate and environmental justice program. So when we talk of both tactical and strategic, what is the need of the time? Tactical, right now, we are looking at cradle-to-gate EPDs. Like we are focusing on cradle-to-gate EPDs, NAPA is focusing on cradle-to-gate EPDs. However, is it sufficient? It's not, because ultimately we have to account for cradle-to-grave. Now, when we want to account for cradle-to-grave, it's not just the industry, but public owners who have to be in place, the researchers who have to be in place to make sure that we systemically account for all these things. Is this something just like a Chait Bhat narrative, or is it somewhere from the standards? It is definitely from the ISO standards. So ISO 21930 that acts as the core product category rule says in its comparability of EPDs that cradle-to-gate EPDs cannot be compared because most of them have declared units. You need to define functional units, as I said, X lane miles of road with Y amount of traffic. So if someone's looking to, like, say, just compare cradle to gate EPDs, how are they making sure that they function or perform properly? So for that reason, these small EPDs can be taken as building blocks, like the data building blocks. But however, in the context, we still need to capture all the post-gate, cradle to gate plus options is what we call it, impacts there. Now, if you want to read more on is it possible or whatever it is, there are a couple of articles that I've written. Dr. Alkadi will be at the TWIG meeting in November. So hopefully we'll have more discussions around the pavement level infrastructure PCR in that meeting, because oftentimes we just think about the current thing, but I think it's the right time to focus more on the post gate by bringing in different stakeholders into the picture. So ultimate goal is to standardize that pavement level EPDs. It's not just going to be material EPDs, but pavement level EPDs. So now we are having material associations lead the process for materials. It will have to be the public owners who will have to take in charge of the post gate, because they don't. The ultimate aim with the PCR and EPD is to reduce the noise and subjective bias that might come in if individual companies or industries take this on their own and do it, because we can, right? Like ISO standard typically says that the manufacturer can define a reference service life. Okay, what does it say? Manufacturer of a polymer modified binder can tell that our polymer modified binder stays for 10 years longer than the others. And the other can tell it's 15 years longer than the others. Are they using the same methods? You have different laboratories here. If you know how significant the results can be when you use different testing methods or even simulation softwares. So we have to bring in all the noises that are existing from the outside, and at an entity like a federal highway where the Sustainable Pavement Technical Working Group is already in place, and talk about these things in more detail. And when I view sustainability as a whole, I feel like if we focus on temporary gains, or if we focus on very narrow boundaries that we draw around ourselves, we are limiting our capability, because there is this term called service life planning mentioned in the ISO 21930 core PCR for EPDs. What is service life planning? Is to meet or exceed a structure's design life. Isn't that all of us what we have been doing? Dr. Alkadi, how long have you been doing this? Meet or exceed structure's design life. So through this sustainability arena, we can bring these things to the more forefront, because there is an emphasis now on quantifying emissions. I see things like warranty-based mechanisms. They have tried those before, but they have not continued with those, because ultimately the rigor that we are having for cradle to gate need to be pushed to post gate as well. And in order to improve data quality, we need to focus things on how are state DOTs deciding on these treatment scenarios. Do they have dynamic pavement management system models? So when I think of low carbon, I don't think of, oh, let's fund this LCA study. But I also think of, let's fund improving this pavement management system, because that will give them better scenarios to optimize the use of materials, which will ultimately reduce the use of materials. So we need to establish those feedback loops. Like state agencies, they might have different divisions within themselves, not really having a data transfer loop. So we need to think of all that when we think of pavement level PCRs. So I'll end with this small example. My mix-up blender recently broke, so I took that example. And this is the more thinner and let's say with more hair version of me. If I was not working for the industry, or if I had not done a PhD, maybe. Let me say on the top, as a student, I went to a nearby Walmart. This most of you might recognize a $10 Walmart mixer blender. And the mixer blender, the manufacturer said it's net zero. So I cared for the environment and I got that mixer blender. However, there's no warranty on that mixer blender. However, now I go to Costco and I get this Ninja blender, $100 worth. It has 5-year warranty. This also claims to be net zero. Now the no warranty one, what happens is, what do they mean when they say net zero, right? They have to account for their manufacturing, the assembly of different parts for that, and the electricity grid from which the manufacturing facility is procuring, which is scope 2. And then ultimately the different material, like different parts of that mixer blender, their manufacturing and the emissions, upstream scope 3. Now I myself, if I think of my carbon budget, I myself will have my own scope 1, scope 2, scope 3s, right? Now the manufacturer of both these are saying they are net zero. But what they are not covering is my downstream scopes. So because their downstream scope 3 will be my upstream scope 3. So they are not covering that. So with the warranty, what I can say is this at least going to be good for 5 years. But then the top one, it just came for first year. And then I had to get another blender and then another blender. What happened here is the manufacturer M1, they escaped by saying they are net zero because there was, think of it as a low bid system. They said they are net zero, but it was just for their compartmentalized net zero. It was not system-wide net zero. Now, if we think of system-wide net zero, it's not just them who should be net zero, but also us. Now, you guys are intelligent enough to make analogies to pavement domain and see where we need to move. So there is an analogy between cradle to grave when I talk about that and when I talk about system-wide net zero. So you have to understand that. So in the building industry, the compartmentalized net zeros are the ones that are failing because they are seeing burden shifting, avoided burden because they are washing their hand that they are net zero. But then the ultimate user is paying for that because they are not getting the materials that they needed. They didn't perform well. Ultimately, we are looking at a multi-objective optimization problem. So in this multi-objective optimization problem, our constraints are not just the performance constraints, are also the cost constraints, but also our carbon constraints. Now I have global carbon budget. If I have to downscale it to country level carbon budgets, and then downscale it to the transportation infrastructure level carbon budgets, and then state level carbon budgets, we will have a number, right? We'll need to take those into account and build a dynamic model and also include stakeholders to prioritize these objectives. How do we see performance? Are we giving equal weights to performance, cost, environmental impacts? Will we get an optimized solution by giving equal weights, or will we not get one by getting, like, say, multiple weights? So this is very context dependent. We can't have one solution for all. We need to look at the context and then develop the solutions. So that was my time. Hope I didn't bore you guys or put you to sleep, but thank you for the opportunity.
Have some time for questions to Dr. Chait.
Yes.
Yeah, thank you so much, Dr. Bhat. I have a question. So is there a plan on electrification of upstream processes and reliable renewable energy in this whole picture?
Yes. So when we talk of the upstream scope 3 manufacturing, or even the scope 2, the electricity grid. So I'll talk about asphalt binder context. So the refiners, many of them are looking to develop their own on-site electricity generation through solar power plants or combined heat and power and other resources. In the upstream, there is the carbon capture sequestration is one of the things that I mentioned that they are focusing on. But in addition to that, they are looking at multiple other solutions, like renewable energy being one of them. If you read the report from International Energy Agency, they talk about the reliance and dependability of the newer renewable energy sector with the existing energy sector. So you'll see a clear correlation between how some of the existing technologies could be used over there. So I see an overlap in the folks who would be developing some of these technologies. So definitely is. Thank you.
Yeah. Thank you for the presentation. You mentioned the development of an EPD web-based tool. I was wondering, like, who would use this tool? Is it for manufacturers, and like, how does it look like? Like, what input would we need for it?
Sure. So her question was, I mentioned about an EPD tool. Who would use it? And so in the context of asphalt binder, it would be the binder manufacturers. So our aim is to have both refinery level and terminal level granularities. So that, so basically asphalt binder flows from the crude extraction to the refinery, where it will have atmospheric distillation, vacuum distillation, and then the post that. Many, as you know, many additives, polymers, modifiers are added to that liquid asphalt that happens at the terminal, which may be co-located with the refinery or separately located than the refinery. So our aim is to account for all this functionality and develop a tool for that. Now for asphalt mixture, NAPA has developed an EPD tool that is used typically by asphalt mix plant owners who look at their cradle to gate and develop numbers for that. Now we don't have anything for pavement level yet. That's what the future thing was. Thank you. And I said nothing, there are pavement LCA tools. Al-Qadi's team themselves have developed a pavement LCA tool. There are multiple pavement LCA tools. Pavement level EPDs are not present yet. You can go ahead.
Thank you for the nice presentation. I have a question. I think there is no deterministic answer for what I appreciate. You could have a high level answer. At the end, you said we have a multi-objective optimization problem that we should consider performance, cost, LCA. How should we assign weight for each of these components to solve this problem?
Now, states like Colorado and California, I'll give you a very diplomatic answer. States like California, Colorado, who already have EPD programs, might assign different sets of weights than other states. Just as an example to give, because it's about individual priority. And like say, if some states have set their carbon budget sooner than the others, they might know a deterministic timeline. And based on that, they might even change the weights over a period of time. Similar to the concept of carbon tax, for example.
Thank you for the nice presentation and forgive my ignorance in this space, but I just wanted to check what is the connection of an EPD at the binder level, which is a component, to the mixture level? Because then if you change your binder, shouldn't that also influence the final EPD of the mixture?
So currently our cradle to gate LCA is an input to NAPA's mixture tool. As we'll have EPDs developed, we'll develop that connection. That is the way we see that organizational transfer happen. Yes, please.
Thank you so much. I mean, that was a very exciting presentation. Congratulations. One of the things that attract my attention in your presentation is you presented very articulately the idea when you have from grave to gate. And while you keep going, you were talking about some of the approaches is to use RAS in order to reduce the use of binder, for example. And that's where the danger is. So when we are looking at from grave to gate, we are missing up maybe with the performance because we're not considering the other ones. And this is the first time I thought that could be really dangerous when we are looking just at the grave to gate.
Yeah, cradle to gate, like just yesterday, I won't mention names, but one of the manufacturers in our PCR committee meeting, the thought process that's going right now is, if you're going to hit us based on EPD number, I'll better put that rejuvenator in a plant than in a terminal. Now, is that going to be an optimized use? Is what we are missing on. But that's not from the fundamental ISO standards. Right? The fundamental standards are telling clearly it's the implementation that needs to take care of it, learn from it and take care of it. Because there is even charts that we have in our LCCA manuals on service lives within the ISO 21930. So performance is a key piece, even when developing an EPD, it's just how we implement it is crucial.
Excellent presentation. I'm trying to follow up and trying to understand actually the word net zero, carbon net zero, right? And I know the downstream, upstream. So you can always have a net zero, some subtraction, but it depends, what you're talking about. What is the range here of, when governments mention about net zero goals like that, or agencies, what extent, what range they cover, and how to look at that.
I'm no expert. I can give you, like say, from where the government policies are getting made. So the IPCC, Interpanel Governmental of Climate Change, they have their own climate models. So they publish assessment reports every 4 years, in which they modify the those thresholds that I mentioned, as well as these characterization factors of different emissions. And then they also suggest, like IEA, International Energy Agency, they take those IPCC reports and then they formulate the change in the energy sector, like for example, based on the demand that's changed, what is feasible to go to more renewables or more stick to more non-renewables. And it's a very socio-politically correlated thing too. Like we saw that a couple of years back, right? So it's not just one context, one solution. They have to look at a range of things. Renewable energy being one of them, but then you have to look at the different ranges, like carbon capture sequestration can be one of the solutions, but it's not going to be one. And that's, you can look at one thing that I would say is different oil and gas companies, they publish energy outlooks every year. And one of the resources that you can look at there is where they talk about how within their context, and similarly electrical commissions and their they publish that. So that would give you more insights on how context specific these things are. It's not going to be one solution that fits all kind of an approach. Yes, please.
Thank you again for the very nice presentation. I enjoyed it. You talk very nicely about the sustainability issues regarding the asphalt supply chain. I am actually thinking a little bit more further about the uncertainty that when we look into the future, and then there are a lot of potential technological advances that we cannot anticipate, and there are a lot of alternative materials as RAS and then RAP, and so I mean that maybe technology will make the performance better. I don't know, but there's also potential suppliers who may or may not continue to supply us, right, in the future. So how from your perspective, your insights is, I want to just benefit from your insights regarding how maybe in your assessments and in your framework that such uncertainty can be addressed.
Yes. So let me limit the scope of asphalt binder. I don't want to talk about other materials. And so for asphalt binder, for example, from the International Agency 22 report, they have 3 different pathways. One is business as usual pathway, which they call as standards SPS scenario. Then they have the advanced pledges scenario. Advanced pledges scenario is basically, as of last year, including US government's pledge to net zero, how would the supply chain change? So for example, will we still have oil and gas? And then how will we still have asphalt binder? And then they have ultimate net zero pathway. So one good thing is from the resiliency of asphalt supply chain, if you look at the announced pledges scenario, heavy bitumen is still going to be produced. I think it's 3.2 megajoules or something of the, you can see the table there, but it's still going to be the similar amount. So in terms of availability of binder, there's not going to be a problem. Now, in terms of how the post-gate scenarios can be developed by pavements, I can't comment on that. It's the public owners and the agencies will decide on it. But in terms of supply chain availability, it's not going to be an issue, is what we have seen from our in-house research. Thank you. Yes, please.
About the implementation of PCR regulations or the tools that you're creating in the future, do you envision that manufacturers are going to be able to use these tools by themselves, or that consultants are going to be taking that niche, that spot for DOTs to trust where these EPDs are coming from? What is your vision on how this?
That's a good question. This last week, I co-presented with Federal Highway and EPA on the topic of quality assurance in the context of EPDs. Because can you trust those consultants? Can you trust these companies? So as we talk, so since all of these have come in place after the previous administration, they are still learning and implementing at the same time. From our end, what we are making sure the tools have is like outlier checks. So there will be third-party consultant who would be signing confidentiality and NDAs with individual manufacturers to provide their primary data, and then have the outlier check inbuilt within the tool. And then third, the reviewer will sign another NDA to make sure that whatever model that they are building is a computationally significant model. And then state agencies are still figuring out what would be their individual quality assurance checks. Like for materials, we have quality assurance, right? The 6 components. How would that reflect into the arena of EPDs? That's still being discussed, and something to watch out for.
Just a follow-up.
Yes, please.
Is Asphalt Institute envisioning to be a certifier in this process, or
not as of now? In terms of, so we as I said, even we did not even become our own program operator because we wanted to avoid any subjective bias right from the beginning. So we chose Smart EPD as the external program operator. Yes, it does add more difficulty because then when you have a third-party program operator, it is a bit different. I would put it in that way. It's a bit different. So we'll have to take EPA, others into account. So we as an association have not discussed yet whether we would be a certifier or whatever, but our aim is to support the members by developing that EPD tool that they could use. And in the process, we are involving Colorado DOT, Federal Highway, EPA to make sure that that's useful to them.
Thank you.
Let's thank Dr. Bhat.